Thank you. Is my screen is visible, ma? Yes, tell me. Is my screen is visible? Okay, done. Thank you, Amma. So, is my voice is audible? No issues. I will connect through the phone only. Just wait, ma. So, up to fourth unit, you came to classes, and after the fourth unit, you have not there for the classes. So, I want to deliver unit 5, which is voltage control. So voltage control is nothing but every distribution system is having a good quality amount of power. quality amount of reliable supply, reliable supply, and good quality. So to maintain the good quality purpose, voltage, this is voltage profile is must to maintain the good profile. So this is about that, and next one is next one is, see, to have the voltage regulation purpose, why we are going for the voltage regulation and what are the importance of the voltage regulation is nothing but when so source is there, loads are available here. Okay, this sudden changes of the load, okay, automatically sudden changes of the load which affects the voltage profile of the source. And with respect to when the load on the electrical distribution system changes, voltage at the customer terminals is also changes. Okay, so when the load on the electrical distribution system is going to changes means voltage profile is also changed, which varies the variations of the voltage, which varies the variations of the voltage at the customer's terminals, and it's undesirable how it is increasing, how it is decreasing. Okay, so you need to keep that in the permissible limit, how much of limit you need to have. Okay, so why we are going for this voltage profile, and what is the importance of the voltage profile is nothing but when you have a sudden change in the particular load, automatically you have effect on the load side and source side also. Okay, on which way you can have, on which way you can have the, what are the reasons to have voltage profile to low. Okay, first one is, first one is lighting loads. Lighting loads. Okay, so lighting loads are nothing but the lamp characteristics. Different amount of lamps are correct, lamp characteristics. These lamp characteristics are very sensitive to changes of voltages. Okay, so this lamp characteristics will varies, and in case of the power loads, okay, when induction motors are connected, IM is nothing but induction motors are connected. Okay, this is consisting of loads. Okay, and when sudden changes of the loads are there, sudden changes needed means which affects the voltage profile. Okay, which affects the voltage profile. And if the supply voltage, so you have a, if supply voltage is more than this, if supply voltage is more than normal condition, okay, the motor may rotates with a, okay, the motor may rotates with a the motor may rotate and operates with a satiatory magnetic circuit, and consequently large magnetizing current will be drawn. And whenever you have the, when the motor is too low, when the, if the supply voltage is too low, which is going to have, it is going to reduce the starting torque. Okay, this is about that. Okay, when supply voltage is more, you have a magnetizing current is more, and motor is affected with the motor is runs with the magnetizing current, and supply voltage is less, you can have motor may starts at motor may which will reduce the starting torque. And so there is another reason to need the voltage profile. Okay, so whenever you are using this distribution system is having various amount of loads are there now. So so too wide variations of voltage causes too wide variations of voltage causes causes excessive heating, of distribution distribution transformer. This may reduce the rating of the transformer. Okay, this is about reasons of voltage profile improvement. Okay, and how to improve methods various methods are there to improve the voltage profile. First one is generator voltage regulators. Number two is installing of voltage regulators. Installing a voltage regulating equipment and capacitors in the distribution substation. This is a another solution to increase the voltage profile. Next one is load balancing. Load balancing on the primary feeder. Fourth one is so you can have adequate size of feeder conductor. Okay, by the next fifth one is conversion of single phase feeder to feeder sections to multi phase feeder. Number six is shifting of loads to new feeder new feeders or new substations and one is construct construct the new substation for the admitting of few purpose. It will take some time now. So and the primary feeder. Next eighth one is increase the voltage levels of the primary feeder. Next, locating best capacitor. Best capacitor. So best capacitor location series mentioned on the primary feeder. So this is about that. So these are all are the things you have. So on that you have only effect of series capacitor. So you know about the series capacitor. So in the transmission line, you have added a series capacitor, which affects the voltage profile improvement. Yes, and here IS, and here IR. You will have here VR. You will have okay, and you have R, XL, and XC. So omega L, omega C, J omega L, J omega C. Okay, so you know that to maintain a voltage at the customer premises within the saturatory limits purpose to maintain the saturatory limit purpose at all the loads is the responsibility of utility. Okay, so this capacitors, okay, series capacitor or shunt capacitors. This is about the series capacitors and shunt capacitor. Series and shunt capacitors. Um, Capacitors can be also be installed in series with the primary feeder to reduce the voltage drop. Okay, indirectly voltage drop is equal to IR cos theta plus IXL sin theta. Okay, this is about that. So you are decreasing this by the using of IXL minus XC into sin theta. You are decreasing the when capacitor is added in series capacitors are added in series. VD dash. Previously, you have this. Okay, and after installing the capacitor, this is the thing you will have. Okay, that is the thing you will have. So you are decreasing the voltage drop, but relatively, but they are rarely employed in fashion. So whenever you are having shunt capacitor, okay, series capacitor reduces the voltage drop, indirectly improves the voltage profile. And shunt capacitor, for the shunt capacitors, so you can have a system. I'm drawing here source. In between that, you have a load. This is about the load. This is about series capacitor. Okay, and shunt capacitors are nothing but this one is shunt capacitors. Okay, so this is about shunt capacitor. So when shunt capacitors are connected in parallel with the load, correct it corrects the component of current. So you are going to change the IC involving IC. So you can have a capacitor. I told you. So Vs, IR, IS. Sorry, IS, R, XL, XC. Here IR. You are going to change it to the IC, and IR dash you will have. Finally, you will have the IR dash. You are going to changing the IR dash, which is less value, less than the IR. So you are decreasing the IR current, so which improves the power factor, which improves the voltage profile also. Okay, which improves the voltage profile. And whenever so this is about the total reactance drop is going to improve. So a capacitor in series with the primary feeder serving a lagging power factor. Okay, this is about lagging power factor. This is about lagging power factor, and that will which will cause a rise in voltage, and load is going to improve, and the voltage on the load side of the series capacitor is raised above the source side, acting to improve the voltage regulation of the feeder. So, since the voltage rise or drop across instantaneously with the variations of the load, the series capacitors response as a voltage regulator is faster than the smoother than the voltage regulators. So, whenever you are going for the voltage regulator, better you can go for the capacitors compensation. Okay, so there is a drawback of this particular series and shunt capacitors. Okay, so the major drawback of this capacitor is which produces high voltage across the capacitor terminals under short circuit conditions. The drop across the capacitor is about the when the faulted conditions if is a current ifxc amount of current you will get, which which is going for the which is going to for the major effect on the, okay, when the short circuit thing is there, you will have if amount of current ixc. So ifxc, this will create huge amount of voltage. Okay, huge amount of voltage which of the many of times of the full load current under certain conditions. It is very essential uh, that the capacitor is to be taken out of service as quickly as possible. So whenever you are having like this a spark gap, you will get a spark gap with a high speed contractor. High speed contracted can be used to protect the capacitors under these conditions. Okay, this is about the capacitors. So regulators. Next one is regulators. All of you follow this. Okay, so automatic voltage regulator on that. Automatic voltage regulators. Okay, you can have A, V, R. Okay, you can have A, V, R. It is also called as A, V, B, automatic voltage balancers. Papa. Go. Boosters. Okay, so this is about that. And automatic voltage boosters. This voltage boosters are used to hold the voltage of a feeder, to hold the voltage of a feeder at a predetermined value within a limit which causes control equipment is capable of maintain and within acceptable tolerance period. So this is about that. So this is about to hold the voltage and to maintain the voltage purpose within a particular limit purpose. You can use the automatic voltage regulator, and regulator may be installed at the substation. This regulator is going to installed at substation installed at substation or feeder line feeder lines feeder lines so are on the poles on the poles. So these are essentially needed auto transformers. Auto transformers. Papa. With the secondary means series portion. The secondary series portion. Okay, series portion of the coil arrange like a auto transformer. You know about the auto transformer. You can have the series portion, okay, arranged so that all are up, a part of the induced voltage can be added and subtracted from the primary voltage. This is about that. And these voltage regulators are classified into two types. Two types. One is induction type. Induction type and step type. Step type are tap changing type. I learned that more. So this is about that. So I'm going for the step type induction type. Papa, Papa, Papa. Stream on, please. Just wait, ma.
నేను రీడింగ్ చేస్తున్నా.
Hmm.
రీడింగ్ చేస్తున్నా.
No issues. Yeah. Okay. Unregulated supply. Madhavi. Unregulated supply. And here in the induction type of regulator, you have another winding which is compensated one, compensated one to compensate the voltage.
అచ్చు.
Yeah. Induction type. In the induction type, you have it's like a transformer or induction motor. But here, regulated supply. Here on the primary winding, you have a one compensatory winding. This is about the primary winding. This is about secondary winding, and which is going to have a at the output we will have a regulating supply. Okay, so this is about that. So whenever you will have, this is about that. So this HV winding, and the primary winding is like a HV. The primary winding is like a HV, and secondary is not in series, and and those are arranged that they are rotate with respect to one another in figure. So the primary coil or the primary winding is usually the starter, and the secondary coil is usually the rotor. The direction of the rotation, direction of the rotation generally depends on whether the incoming voltage is to be raised or lowered. Okay, so the voltage induced in the secondary is or in series winding will depend on the position. Okay, so depend on the position in relation with the primary winding. Depending on the position, the induced voltage can be added or subtract by the input voltage to add. So whenever you will have a higher amount of here less amount of voltage, you need to add some series winding, okay, by the using of the compensatory winding, okay, to improve the voltage profile during the rotation of the primary coil. The moving magnetic field can be caused a large, okay, the moving magnetic coil, this compensatory winding is for the moving only. So the moving magnetic field can cause a large reactance voltage drop in the secondary. To cancel this effect, third coil, okay, to cancel, this is about to cancel this effect purpose, the third coil is mounted at right angle to the primary coil on the movable core and short circuited on itself. Okay, the moving part primary coil will induce a voltage in the third coil, which will in turn set up moving magnetic field of its own. Okay, some of them are in this induction type of regulator is having two types, like a moving as well as stationary. When stationaries are there, this compensatory winding will rotate, and when rotating one is the primary winding and secondary windings are there. With respect to the rotating, you will have a third one. So to without rotating means you need a rotating. So at the primary right angle to the primary coil, a movable core is installed, and which is short circuited on itself, which is short circuited. Okay, and 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 otherwise you can have the moving primary coil will induce a voltage in the third coil, which will in turn set up a moving magnetic field of its own, so which will tends to oppose that setup by the motion of the primary coil. The reactance of the regulator unit is thus kept essentially constant. The reactance is going to maintain as a constant. This is about induction type of thing. Okay, this is about induction type of thing when it is having and you can have the step type of regulator. Okay, so step type of regulator I am right drawing. Same you will have. So you can have at the secondary side you have a more winding step up type of thing. So this is about the primary coil. This is about secondary coil. Okay, here unregulated voltage. Here regulated voltage. So this step type of regulator is classified into two types. First one is station type. Second one is distribution type. Station type is having a single phase. We have a classification single phase and which is available single phase and three phase, and it can be used in the substation for bus bar bus voltage regulation or individual feeder voltage regulation. Okay, and this distribution type of voltage regulators, this old distribution type of voltage regulators, which can be used only single phase. Okay, only single phase, and used for pole mounted on overhead primary feeder. Okay, overhead primary feeder. Still some of the people. So these are the so it is very very essential, essentially an auto transformer, and is connected to a is connected in the feeder as same manner as on the induction regulator. This type does not employ rotation of the one of the coils, but changes voltages by means of taps in the primary coils. Okay, so most of the regulators are designed to correct the line voltages from 10% boost to 10% buck in 32 steps. Okay, like you have a, so 32 steps are there like this. Okay, so you can have a piston to have the voltage regulator. Okay, at the secondary side you have like this. Okay, 32 steps are there. Okay, with the 5 by 8 it's around zero point 0.5, zero point 6 voltages, 0.60, 60% voltages changes per step. And in addition to its automatic auto transformers component, a step type of voltage regulators also has two major components, namely tap changing and control mechanism. Each voltage regulator is consisting of necessary controls and accessories, which are having the automatic tap changes, and which is responsible to a voltage sensing control to maintain the to maintain a predetermined predetermined output voltage by receiving its inputs from PTs to the CTs. PTs are nothing but the potential transformer to measure the voltage, and CTs are nothing but the current transformers to have the current. And whenever you have the voltage increment or current increment, which will detect, and you can have the control. The control mechanism provides the control of voltage level and bandwidth. Further,
It provides the ability to adjust line drop compensation uh, by selecting resistance and reacting settings. Okay, this is about that. And how you can control the control and rating of the voltage regulators is nothing but this rotation of the primary coil in the induction type of regulator, and a tap changing transformer in the step type of regulators are controlled by the voltage regulating relay. Like a voltage regulating relay is connected. So voltage regulating relay is connected means, which is also known as contact making voltmeter, connected to the output side of the regulator, which is associated with the line drop compensate, which is essentially a essentially a very good thing for that. And ratings of the regulators is based on their nominal voltage classification and their changes of the voltage percentage of the voltage regulation. Therefore their kVA rating as a percentage of the volt amperes transformed is the same of the percentage voltage transferred using the incoming primary voltages as a base. This is the same rating used for the auto transformer. So automatically you can have plus or minus 10 percentage boost or purpose bucking purpose. You are going for these two type of things. Okay, and the last topic is nothing but line drop compensation compensator. In general, voltage regulators located in a substation on a feeder are used to keep the voltage constant at a regulating point without changing magnitude and power factor of the load, where it is designed to regulate or so can I tell the tomorrow's class? I'll take the tomorrow's also. So I'll draw that. So on the line, this line drop compensation, I'll draw first. On these are the lines. So you have the CTs and PTs are there. Na? CT is connected. Here high amount of current. And PT is connected here in parallel to the line. So this CT is having a connection with the R, some amount of impedance. So the secondary winding of the PT, you can connect to the R, and you can have a another winding which is balanced by the controlling with the reactance, and this will control the balancer, which is going to have a regulated output regulation control. Okay, this is nothing but a this particular thing is nothing but a voltage regulating equipment. Okay, CTs PTs are connected to the voltage regulating equipment to maintain the particular thing. Where you have this connection is nothing but whenever you have a substation you have, and on the substation you have to the feeder which is connected to a voltage regulator, and which is given to the laterals. All of you remain. Okay, so this is about that. This is about the line drop compensation. I have given the notes. On the notes you have everything. Okay, please follow that. Right now I am closing this today's class. Thank you everyone for the joining. I think you have a um, Akash. Akash,
Sir,
I want to take more classes for the revision. I need a few other people are also asked about my classes. So I need your leisure hours. Please mention your leisure hours to personally. You can ping me and you can mention your convenient time. By the asking of your friends, you can give me your timings also. Is it
okay,
okay?
sir. Okay, sir. I
Okay.
will inform you.
Okay. What about Neeraja? Neeraja and Pravalika? Are there? Okay, sorry. Those are not
Not
there.
there, sir.
Okay. Okay, ma. Right, right. I'm closing now.